All right, you guys, in this section, we're going to talk about inverse functions. So our formal definition for inverse function says, suppose that f is a one-to-one function, then corresponding to each x in the domain of f, there's exactly one y in the range because f is a function, and corresponding to each y in the range of f, there's exactly one x in the domain because f is one-to-one. The correspondence from the range of f back to the domain of f is called the inverse function of f. The symbol f to the negative 1 power is used to denote the inverse function of f. Okay, so I know reading that definition is probably a little confusing. All right, so let me try to explain it a different way. All right, so let's say that we have a function. Okay, we know that our notation for function is f of x. Okay, we have two different sets. The values that go into our function, okay, those are called the values that are contained in the domain. Okay, actually, let's write it in a different color. Okay, so we have our function. The values that go into the function are the values that are considered in the domain. And then the other set that we have are the outputs, or the y values. And we say that those values are the range. Okay, so our definition of a function says every x has to have its own y. Okay, and it also says that in order for you to have an inverse, not only do you have to be a function, but you also have to be one-to-one. Okay, and we know that. So first you have to be a function, then you have to be one-to-one, then you can have an inverse. Okay, so if you're thinking about these like levels, having an inverse function would be the third tier. Okay, so you have to be a function, then be one-to-one, then have an inverse. So if I were to draw that, it would be like every input value in the domain is matched to exactly one output value in the range. So this is a function, but it's also one-to-one. Okay, it says if you meet these conditions, okay, then you will have an inverse function, which we denote as f to the negative 1 power x. Okay, and what the inverse does, it allows us to go backwards, if you want to think about it like that. It will map every value that's in the range back to the domain. Okay, so that we have something like this. Okay, so when it comes to the inverse function, okay, we weren't moving, if you're thinking about this picture, we weren't moving from left to right, we were moving from right to left. So all of the values that are in this first set, all right, for the inverse, these would be considered the domain values because they are the inputs for the inverse, which would make this other set the range. Okay, so notice I didn't change any of the values that were actually in either of these two sets. Just depending on which one I was talking about, either the function or the inverse, dictated where I was starting. Okay, so an example of this, okay, because I know sometimes this may be a little confusing. If you want to think about a crime scene, okay, so let's say you're visiting a crime scene. I don't know why. Let's just assume you didn't commit a crime. Okay, so let's say that I burglarized a house. Okay, so you have me. Okay, I go into this house. All right, and as I'm stealing, okay, I leave behind my handprint. Okay, I am not an artist, so do not judge me. All right, so I go into the house, leave my handprint. The first thing that's going to happen when the crime scene investigators show up, okay, they are going to dust for fingerprints. Okay, and then if I'm in the system, my fingerprint is going to lead back to me. Okay, so the process of me leaving my handprint in the house, okay, that is the function. Okay, and not only is it a function, it's a one-to-one function because my handprint is unique to me. Okay, our handprints, our fingerprints, our DNA is individualized. Okay, so it's a function and it's one-to-one. So since it was a function and it's one-to-one, there must be a way that I can insert that information backwards, okay, or input it backwards. So the crime scene investigator coming and finding my handprint and my handprint leading back to me, that would be the inverse function, okay? Notice that my handprint and myself, we didn't change in either one of the scenarios. It's just the order in which they came. So me leaving my handprint is the function. Having my handprint and leading it back to me is the inverse, okay? So I hope that example helped a little bit, all right? So we're going to work more with inverse functions. So let's take a look at this example. So this example says, find the inverse of the following one-to-one function. And they give us a set of ordered pairs, okay? And it says, state the domain and the range of the function and its inverse, okay? So it's important to note that it's levels. You first have to be a function. You then have to be one-to-one. And then you can have an inverse. Okay, so as we are solving these problems, it's important that they categorize these for us, that they tell us what we're working with before we attempt to do something else. So they already told us that we have a one-to-one function. Okay, they told us that. So if it's a one-to-one function, we've satisfied the conditions of it being a function and one-to-one. So yes, we can find the inverse. So it's possible to do what they are asking. Okay, so the other thing that we just saw from our example, okay, is that the inverse and the function, their data points are in reverse order, okay? So if I'm looking at this set here that they gave me, okay, and if I am asked to find the inverse, all I'm going to do is switch the positions of the numbers. So the domain and range of the function flip-flops when you are talking about the inverse. So nothing happens to the signs of the numbers. It's just simply that the numbers switch positions. So if I'm talking about the inverse, this first coordinate is going to be negative 27, negative 3. This next coordinate will be negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, 8, 2, oops, ran out of space, and 27, 3. Okay, so notice none of the signs changed, just my numbers changed positions. Okay, so now they're interested in the domain and the range. Okay, well, we know that the domain, all right, of the function, so let me keep them in the same color for you guys. Okay, so when I'm talking about the function, I'm going to use green. Okay, so for the domain of the function, we are talking about the x values. So anytime we're asked to list the domain, we're always going to list our values from smallest to greatest. Okay, so that's going to give us negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay, this is for the function. All right, and then let's look at the range of the function. All right, and the range of the y values, so smallest to greatest, negative 27, negative 8, negative 1, 0, 1, 8, 27. Okay, now if we're asked to do that same thing for the inverse, okay, we're going to do the same thing. We're going to list the x values, so the domain for the inverse. Okay, so I'm going to look at this set that I wrote secondly. So that's going to be negative 27, negative 8, negative 1, 0, 1, 8, 27. Okay, and then if I'm asked to find the range of the inverse, I'm going to list the y values. So it's going to be negative 3. Oh, this should be a negative 2. Sorry. Negative 3, negative 2, negative 1, 0, 1, and 8, and 27. Okay, so what you will notice, okay, whatever was the domain of the function, okay, is the same exact thing as the range of the inverse. Okay. So did I mess that up? Yeah, sorry guys. All right, hold on. Let me fix it. Okay, so for the range of the inverse, let's see, -3, -2, -1, 0, 1, 2, 3. These ones are messed up. 2, 3. There we go. Okay, so what you will notice is that the domain of the function is the exact same thing as the range of the inverse, okay? If you look at those two sets, their numbers are identical, okay? The other thing that you will notice is that the range of the function is the exact same thing as the domain of the inverse. Those sets are exactly the same, okay? So essentially, all I had to do was find the domain and range of the function, and then I could have just flip-flopped them. So I would have automatically known that the domain of the function is the range of the inverse, and the range of the function is the domain of the inverse, okay? So they will always share that relationship between their domains and ranges. Okay, so this is another way to think about it. So by definition of the inverse function, the domain of f is the range of the inverse, and the range of f is the domain of the inverse. Okay, so that same similar picture that I drew you guys before, if you know what the domain is of the function, you also know the range of the inverse. If you know the range of the function, you also know the domain of the inverse. Okay, so these two sets are always going to be equal. Okay, cool. All right. And this is just another way to look at it. Okay. Now, we've talked about composite functions before. Remember, that's when we were talking about, let's change our color. When we said f composed of g, you guys remember that? Or we could write it like this, fog of x. Okay, so anytime you are trying to check if, let's say I give you two equations and I ask you whether or not those equations are inverses of each other, okay? One way that you can check is compose them, okay? So if they are in fact inverses, if you do the inverse composed of the function, it should give you x. And if you put the inverse inside of the function and simplify it, it should also give you x. If both of these conditions are met, then the two functions that you've been given, yes, are in fact inverses of each other. Okay, so this is something important to keep in mind. If you can compose them of each other, then yes, they are inverses. Cool.